Have you ever clicked on a button on a web page and nothing happens? The whole page just freezes up? Well, you've probably run into one of JavaScript's most powerful and honestly most confusing features, asynchronous programming. In this explainer, we are going to pull back the curtain and demystify what's really going on with callbacks, promises, and async/await, so you can build those super smooth, lightning-fast web experiences. So, let's kick things off with a very real-world problem. Imagine you've got a button on your site, and when a user clicks it, it has to do some heavy lifting. Say, it takes 5 whole seconds to finish. In a simple, synchronous world, the second that button is clicked, the entire page locks up. It's frozen solid. No scrolling, no clicking anything else, nothing. For the user, it feels like the app is completely broken. This is called blocking, and it's the big problem we're here to solve today. You know, developer Jake Archibald came up with the absolute perfect metaphor for this. He said, a long task is like a sneeze. For that split second, your entire body just stops. The same thing happens on a web page. The page can't draw anything new, it can't respond to your clicks, it's just stuck. So our whole mission here is to figure out how to manage these sneezes so our apps stay fluid and responsive. So here's our game plan. First, we're going to really dig into what this sneeze is all about. Then we'll pop the hood and go right inside the engine room, the event loop. From there, we'll look at the old way of doing things with callbacks, then see how life got way better with promises. And finally, check out the modern async await syntax that makes it all feel kind of like magic. By the time we're done, you'll know exactly how to cure the sneeze for good. All right, let's dive right in. Section 1, the JavaScript sneeze. Before we can fix this thing, we need to understand what's actually causing it. Let's look at 2 bits of code that look pretty similar, but behave in wildly different ways. Okay, take a look at this. On the left, we've got a super simple while true loop. If you run this in your browser's console, I guarantee it will freeze that tab instantly. It's a total classic sneeze. But now look at the right. We're also doing a loop, but this time we're using something called setTimeout. This version, it doesn't freeze the UI at all. The page stays completely responsive. Now, they both kind of do the same thing, but one is a blocker and the other isn't. The key to understanding all of async JavaScript is right here, in answering one simple question: why? And to answer that why, we've got to look under the hood. The big difference between those 2 loops is all thanks to JavaScript's concurrency model, which is powered by a mechanism called the event loop. This is the real engine of asynchronous JavaScript. First up, you've got the call stack. The easiest way to think about this is as JavaScript's single to-do list, its workspace. And it is single-threaded, which is a fancy way of saying it can only do one single thing at a time. When you call a function, it gets pushed onto the stack. When it's finished, it gets popped off. Last one in is the first one out. Now, remember our while true loop? It gets on the stack, and it never, ever leaves. It just sits there, blocking anything else from ever running. But here's the secret sauce. The JavaScript engine isn't working all by itself. The browser gives it a whole team of background assistants. We call them web APIs. So when JavaScript sees a task that's going to take a while, like a setTimeout timer or a fetch request to get some data, it can just hand it off to these APIs. This frees up the main thread to keep on working. So what happens when one of those background assistants finishes its job, like the timer finally runs out? Well, the result doesn't just jump right back into the main workspace. Instead, the function that needs to run next, we call that a callback, gets put in this waiting line called the task queue. Just think of it like an inbox for all your completed tasks, all lined up and patiently waiting for their turn. Okay, let's actually trace the journey of our non-blocking setTimeout and see how this all works together. 1, we call setTimeout and it lands on the call stack. 2, right away, it hands off the timer to the web APIs, and boom, it pops right off the stack. 3, and this is the most important part, the call stack is now empty. The main thread is free to do other things, like respond to user clicks. 4, a little while later, the timer finishes and its callback function gets moved into the task queue. And finally, 5, the event loop, which is this constant process that's always checking, asks, hey, is the call stack empty? Yes, it is. So it grabs the first thing from the queue and pushes it onto the stack to be executed. This whole cycle is how we get work done without freezing the page. So, this whole idea of passing a function to be run later, that's a callback. And for a very long time, this was the way you handled async code in JavaScript. It was how you told the browser, hey, when you're done with this long thing over here, please run this function for me. Now, callbacks work, sure, but they have let's call it a dark side. What happens when you need to do a few async things one after another? Well, you end up nesting callbacks inside of other callbacks. And that leads to this infamous pyramid shape you see here. We call it Callback Hell or the Pyramid of Doom. And trust me, it is an absolute nightmare to read, to debug, and just to figure out what on earth is going on. Obviously, Callback Hell just wasn't going to cut it long term. So to fix this mess, JavaScript introduced a much more elegant idea: promises. A promise is really just an object that represents a future value. It's like getting an IOU from the browser. It says, I promise I'll get you a result from that async thing you asked for as soon as it's ready. Every promise has its own little journey. It always starts out in the pending state. And from there, it can only go one of two ways. It can either become fulfilled if everything went well, or it can become rejected if something went wrong. And the most important rule here is that this is a one-way trip. Once a promise is fulfilled or rejected, we say it's settled, and its state can never, ever change again. And this is why promises were such a game changer. Look at this. By using a method called .then, we can chain our async operations one after another in this flat, sequential way that's so much easier to read. Each .then gives you a new promise, so you can just keep adding steps to the chain. The pyramid of doom, it's gone, completely flattened out into something we can actually understand. Okay, now stick with me here because this is a really subtle but incredibly important detail. Promises don't actually use that regular task queue we talked about. Nope, they got their own special, separate queue called the micro task queue. You should think of this as the VIP line at a club. The event loop has a very strict rule. After it finishes any task, it must check the micro task queue and process everything in it before it's allowed to even look at the regular task queue. All right, pop quiz time. Let's test that idea. We've got a timeout with a 0-millisecond delay, so it's going to put its call back in the task queue basically right away. And we have a promise that resolves immediately, which will put its .then call back in the microtask queue. So, which one do you think is going to log to the console first? And the answer is the promise. Why? Because its callback went into the high-priority microtask queue, that VIP line. Even though the set timeout had a 0 delay, its callback still had to go to the regular old task queue, and the event loop's strict rule says it has to clear out the VIP line first. So in the battle of the queues, microtasks always win. Promises are awesome, no doubt. But what if we could make the code look even cleaner? Well, that brings us to the most modern and frankly the most readable way to write async code today, async and await. So how's this work? Well, async await is really just a beautiful new syntax built on top of promises. When you mark a function as async, you're basically telling JavaScript, hey, this function will always return a promise. Then inside that function, the await keyword does the real magic. It pauses the function, waits for some other promise to settle, and then unwraps the value for you. No more .then needed. I mean, just look at the night and day difference here. On the left, we've got our promise chain with .then functions. It's way better than Callback Hell, for sure, but you still have these nested functions. Now look at the right. With async/await, the code reads like a simple top-to-bottom story. First, we await the fetch, then we await the JSON. There are no callbacks. It's just clean, linear logic that looks and feels like regular synchronous code. It is so much easier to write and to debug. Okay, time to bring it all home. We started this whole journey with the JavaScript Sneeze, that annoying frozen UI from a long-running task. Now that we understand the event loop, queues, and async await, we can finally cure it. So let's trace our final sneeze-free solution. We call our async function. The fetch request is handed off to the web APIs to do its thing in the background. Then we hit await. And this is the magic moment. The await keyword pauses our function only, not the entire browser. The call stack completely clears out. This means the main thread is free, the UI is responsive, no sneeze. Then, when the network data comes back, the promises result gets put in the high-priority microtask queue. The event loop sees it, picks it up, and our function wakes up and resumes right where it left off. That is how we get smooth, concurrent code without blocking. So there you have it. We went from a frustrating blocking sneeze all the way to a smooth, responsive app, just by understanding what's going on in the engine room. The event loop, the different queues, and these amazing modern tools like async await. They give you the power to control the flow of your application. So the real question I have for you is, with this new mental model, what sneezes are you going to go out and cure in your own projects? Thanks for joining this explainer.